Okay, so for the first part of this unit, we're going to go over some terms and definitions that you need to know in order to kind of understand exactly what we're talking about. So some of these will be really easy, some of them you've seen before, and some of them will be new. So the first thing we're going to talk about when we're talking about parts of circles is actually what is a circle. So a circle is defined as a set of points that are equidistant, that means equal in distance, from a given point, which we call our center. So a circle, we have a center, we're going to call that P. So this would be called circle P. We name it by its center. And it's really just a set of points that are just equidistance from that center point, and they make up this circle. Okay, a radius is a segment with endpoints at the center and on the circle. So it is a distance we can measure. So we have our center, and then a radius is any sort of line segment that runs out from this center. So if we're looking at our visual for the circle, it would go to all those points. It just goes to any point that's on that circle. Okay, we have a chord. A chord is a segment with endpoints on the circle. You'll notice it does not say that it goes from the center. So a chord is different from a radius. So a chord could be like a point here and a chord and a point here, and it's running like that. So it just has endpoints on the circle, and it's a line segment. So if we call that JK, that would be line segment JK, and it would be a chord because it's not running through the center. A diameter is a chord that passes through the center. So again, a diameter has endpoints on the circle, but this is a chord that passes through the center. And then it's important to know that the diameter, to calculate its length, is just 2 times the radius. So if our center P is here, our diameter would be running through endpoints on the circle and running through that center. All right, a secant is a line that intersects the circle in 2 places. So this is different than a chord because it's a line and not a line segment. So it keeps going on. It just kind of like runs through this circle. So if we had like X and Y, then our secant line would be like this. Okay, then we have a tangent. This is a line that intersects our circle at exactly one place. So if it intersects more than once, it's a secant. If it intersects only one time, then it is a tangent line. And again, it's a line, so we'll say that's Q, R, and we'll call that P. So then we have a point of tangency, and the point of tangency is the point at which the tangent line intersects. So on our picture, this would be that point Q. That is our point of tangency. right, then we have a central angle. This is an angle with a vertex at the center. Remember that vertex of our angle is like your middle letter. And it has two sides that are radii. That means it's an angle constructed by the center, and then we have a radius and another radius. So this central angle will be called angle APB. Remember, we're going to name angles with 3 letters. All right, an inscribed angle is an angle with a vertex on the circle. So this is different than a central angle because a central angle has our vertex in the center, and an inscribed angle has a vertex that's on the circle. And then 2 sides are chords. So remember, chords don't run through the center. So we have A, C, and B. An inscribed angle would be 2 chords, and it has a vertex that's C. It's on that circle. And this would be angle ACB. All right, we're going to talk about arcs a lot. So what is an arc? An arc is a portion of the edge of the circle defined by 2 endpoints. So our symbol for this is exactly as it looks. Our symbol, when you're defining an arc, you're just going to put this over it, and that defines it as an arc. All right, so I'm not going to draw a picture for an arc because we're really going to always just talk about 2 kinds of arcs. We're either going to talk about a minor arc or we're going to talk about a major arc. So let's talk about those, and then we'll draw pictures for those. So a minor arc is an arc with a measure less than 180 degrees. We define this with 2 letters. So if you have 2 letters and the arc symbol over it, you know that that's a minor arc and that the measure is less than 180 degrees. So if we had, I'm going to go ahead and draw this on our other picture because I'm going to do the same. So this is A, B, and C. A minor arc would be like AC or AB because you can see those are less than 180 degrees. But we're just going to go ahead. If we were to draw this arc, we would highlight here AB, and we would call that piece arc AB, minor arc AB. All right, so if a minor arc is less than 180 degrees, a major arc is an arc with a measure that is greater than 180 degrees. And we use 3 letters to name a major arc. So if we had, again, our 3 points, we would, a major arc would be like this arc right here. And we could call this arc BCA, or we could call it ACB, and then we put our arc symbol over it. And that would determine that this is over 180 degrees and this is a major arc. All right, then we have a semicircle. So a minor arc is less than 180 degrees. A major arc is more than 180 degrees. What about if it's 180 degrees? So if it's exactly 180 degrees, then it's a semicircle. So this is an arc with endpoints on the diameter. So remember that diameter runs through the center, 2 endpoints. and it includes the radii. So this is always equal to 180 degrees. So this has to run through the center. It's on our diameter. If this was J and L, let's call this K, and there's our little center P. Then we would name this JKL. That's our arc JKL, but it's a semicircle since it's running through that center. All right, the last thing I want to do, we're going to write these down. We're going to talk about them in greater detail, but these are just some special formulas to remember that we're going to talk about in this first section. So we have the area of a circle, which you should already know, and that is the area of a circle is just pi and the radius squared. The circumference of a circle, which is that distance around the circle, is either 2 pi times the radius, or remember that the diameter was just 2 times the radius, so we can also say the circumference is pi times the diameter. And then we have arc length. So we'll be calculating the length of those arcs. Remember, it could be a major arc, a minor arc, or a semicircle. And so we have this L for arc length, and that equals X times C over 360. And in this, X is our measure, and C is our circumference. So you'll have the measure of your arc, the degree measure, and then C would be either, if you're given the radius, it would be 2 pi r, or if you were given the diameter, it would be pi times the diameter. But we're going to talk about those equations in greater detail in the next videos.